So welcome to the next video in the series on exploring agentic systems in KNIME. I want to share with you a little bit on the progress that I've made since the first video in the series. And to sum it up, I managed to improve the web search tool. So I went down the path to develop my own node for that uses some Python packages like DuckDuckGo Search and Goose3 to get much better results without opening the browser. And I also managed to progress with developing additional tools. So there will be two new tools. One of them is a retrieval-augmented generation, in short RAG tool, that allows you to chat with your own documents, so to speak. And for demonstration purposes, I've loaded and prepared the KNIME Python extension development documentation that we can interact with via an agent that uses this tool. The next tool is a database query tool. So this tool allows an agent to extract information from a database based on natural language questions. And to demonstrate this, I've tapped into the data that was generated during my financial modeling in KNIME series. And then I've put that all together in a new example that we will see in just a little bit, which is a personal assistant agent that delegates my questions to specialist agents. So first of all, there's a web search agent that uses a new web search tool, and this agent will be tapped whenever there's a general question on recent information. Then there's the database query agent, which can interact with the financial reporting data. So any questions related to that will be routed to that agent. And the last agent is the RAG agent. So any questions around developing Python nodes for KNIME will be routed to that agent. And the agent orchestrator, as per usual, is one who extracts what my question is about and decides which agent gets to act next to give a final answer to me. So the structure of today's video is a little bit in reverse what we did last time. So I will start with the demonstration of this personal assistant. And one thing in advance, I managed to record all of that in one session. So there were no breaks and the agent was able to deal with all the questions without interruptions. Second of all, I want to showcase one of the benefits that I see with developing this type of agents in KNIME, and that is the ability to really follow through and click through what is going on and what the agent is currently doing. After that, I will share with you how these agents can be defined and loaded into my system for now. And lastly, I want to give you a glimpse under the hood of the generic tool agent and how it works on a high level. So without further ado, let's get into that and let's have a look at this demonstration. So this view may look very familiar to those of you who watched the last video. On the right hand side, you see a chat-like interface, which shows what the agents are responding to each other. And on the left hand side, there's a bit of a newer interface, which allows me to actually change the questions that are being sent to the agent. So the first question is querying the database about what the total revenue in 2025 in a specific version of my financial reporting database was. And as you can see, initially the agent orchestrator extracts the question and then starts the process of working out which agent should act next. And that can take a moment. So now I've refreshed again, and you can see that the agent orchestrator has decided to give this task to the SQL query agent. And the SQL query agent used the SQL reporting tool and actually got a number, 103,000. And now the last agent to act is the response formulator. Who now starts working on providing the answer, and the answer is actually correct. And I also managed to validate that by looking into the database manually myself. So very pleased with that. So let me now just clear the message history and let's paste in the next question. The next question is the same that we used last time to test the web searching tool. Who are the favorites to win the 2024 Men's Ironman World Championships? So at this stage, this question should be a little bit more difficult to answer because the race has finished two to 3 weeks ago. So there should be a lot of information about the actual winners already. But the goal here is to see if information on the pre-race favorite can be extracted. The agent orchestrator picks the web search agent for this task as intended. And now the difference to the first video is that I have configured this tool to work in what is called headless mode. So there won't be a browser opening, so we cannot observe where the agent actually is navigating to. Although there is a version for this tool where that still works. And the agent orchestrator could direct the web search agent to use the tool in the mode where the browser still pops up. So here you can then see the output from the search tool. So that is much better. The search tool is very good at identifying what really matters in the data. So a lot of cookie information that was clumping up the data last week in the first version of the tool is not there anymore. And now the response formulator has been tasked with taking the search results and crafting a response. So on the right hand side, you now can see a lot of the raw inputs once again that the response formulator now has to digest. And on the left hand side, you can then see in that gray bubble the actual shortened response, which is of good quality from my perspective and doesn't really spoil the results of the race. So now let me clear the conversation history once again and let's grab the last question. And this is to test the retrieval-augmented generation tool. And the question that I want to pass in is around how I can get started to develop my first KNIME Python-based extension. And what I would expect here is the agent orchestrator now understands that this information is available to the RAG agent and that the RAG agent then is tasked to find information in the vector store that holds all the data and then tells me how to get started. So the first step worked all right. The RAG search agent has been tasked. And he's using the extraction tool, and we can again on the left hand side in the gray box see the best hits that were found in the vector store. And the agent orchestrator then delegates the next step of the process to the response formulator, who has access to the information that the RAG agent extracted. And there you have the succinct and concise answer from the response formulator. So overall, I'm actually really pleased how this worked out and that this all worked out also in one sitting. I'll be honest, there were instances where the agent orchestrator got confused, and after doing a web search, then asking the RAG search agent to search. So there was a lot of prompt, let's call it optimization, required to get this to work sort of reliably. And yeah, that reliable outcome is what you managed to witness just now. So next, as promised, I want to share with you one of the benefits, which is, let's call it observability of what's going on while the agents are working. So what you can see here are the two components that I have right now. On the left-hand side is that chat interface that we saw in the demonstration already. And on the right-hand side is the agent loop, which is, from a user interface perspective, the left-hand side of the demonstration where I pasted in the questions. So let's now start up the agent loop and let's click through it a little bit. Let's open up the component view so that I can paste in a question. And once I hit the send button, you will see that this component starts executing. Once it starts executing, I can actually start clicking inside of it. And inside this mess of nodes for now, apologies for that, you can see that a call workflow service node is executing. And this call workflow service node actually calls a separate workflow, which is the generic agent. In this workflow, I can actually open up and now observe how it's executed. So right now it's preparing to execute the chat model prompter. But if I click on this meta node, you can see that it's the agent orchestrator that's about to act right now. So now the chat model prompter is executing. And the next node, the meta node, takes care of checking the provided response against the response format that the agent was asked to adhere to. As long as he adheres to it, the recursive loop ends. If the format does not adhere to the required structure, then there will be another iteration where the agent is asked to correct itself. In this case, the agent orchestrator gets it right first shot, so the loop ends. And as you can see, with the blink of an eye, now the SQL query agent is acting. And as this agent has access to the database search tool, I'll just prepare to open up the workflow, which represents the search tool. And as I scroll to the right, you can see another call workflow service node, which is right now executing just in time as I'm opening it up. And here you now see the workflow that is behind the tool. And before we know it, it's already executed and it has pulled out the number that you may remember from earlier. And if I now click back into the main loop, you can see that the first call workflow service, the agent orchestrator, is acting again. And inside that generic agent, we can see the prompt and how the chat model prompter is executing already. And now, before we know it, the agent orchestrator has tasked the response formulator, which likely will wrap up our workflow. So now we can inspect the chat window where all the agent outputs were recorded. And here you can see the final response from the response formulator. And that wraps up this section of the video. Let's now jump into learning about how I actually define these agents and the logic behind it. So in general, all my agents are defined inside an Excel file with a bunch of different columns. For example, you can see the agent name and also the column that indicates whether this agent is the last one to act. And of course, of those, there's only one. Then there's the important column of the agent description. This column is especially important because this is what is being passed to the agent orchestrator as a description of the agents that are at his disposal. So based on this description, the agent orchestrator will decide which agent is the best one to act next. Then there is the system prompt and the user prompt defined for each agent. And here I actually want to highlight the way that this prompt is structured. I'm using a technique that I had a lot of success with in order to make large language models do what I want and to improve the quality of responses. And that is to structure my prompt in an XML or HTML style. So you can notice that the system prompt for the web search agent is nested inside agent tags. And then inside these agent tags, there are additional tags like name, like role, like goal, process, and also response instructions. There are also some special XML tags in there. For example, the state var tag that is around the available tools keyword. And then also inside the instructions, you can see that the agent is asked to nest his response inside specific tags, for example, tool input and tool name below that. Asking the agent to wrap his responses inside these tags is actually a very important key concept that allows the agents overall to work inside KNIME, because by wrapping the responses inside these tags, it is fairly easy to extract them later on and to make sure that a response that is required for the next agent to act can be saved into what I call the agent state. And passing information to an agent is exactly the purpose of the state var tags. Nested inside this tags is what I called a state variable. This is some piece of information that is generated whilst the agent workflow runs, either by being provided by an agent that nests his responses in the corresponding tags, or by the general workflow logic, as is the case with the available tools. Available tools here is a placeholder that will be replaced by the names and descriptions of the tools that are available to an agent to be utilized. Another example can be the state variable user question. Concretely, this means that the agent orchestrator is tasked to extract the user question from the initial user message and is asked to nest it inside user question tags in his response. The search agents that follow then have a placeholder for user question inside their prompt, and this user question is nested inside these state var tags. This way, the extracted user question is passed to the search agent for further processing. This was an example of the system prompt, but the same works for the user prompt. You can also see that there are expected state variables defined in a column. For example, tool input and tool name for the web search agent. And by defining them in this column, the agent workflow will enforce that these variables need to be present in the response. And if they are not present, then the agent will be asked to correct itself. Let's now zoom out a bit and take a look at the remaining columns in this spreadsheet. Further to the right are then the model provider, so that can be Olama, Grok, OpenAI, whatever. The model name and the base URLs, as well as settings like temperature, max tokens, and then some other settings that I won't explain in detail, like collect outputs, collection variable, and then of course the available tools to the agent. As you can probably guess, there's a lot of prompt engineering going into defining such an agent workflow. And that's where it's really good that we don't have to worry about coding too much if there is an agent framework or a component that can be used out of the box. Let's now move on to the last item on the agenda, that is a detailed walk through the generic agent workflow. So as you can see, this is a workflow that is called using call workflow service nodes. And as a consequence, there are a lot of workflow service input nodes. At the very top, there's a node that accepts a variable as input, and in the variable stream that is being sent to this workflow, there are, for example, the agent names and the agent prompt templates. If I now scroll down a little bit, we can also see that these state variable tags, so the placeholders, are still present in this prompt template, like the state var for the user question that I explained earlier on. Next node after this variable node is a component node. So all the relevant variables that the agent needs to progress are being collected in configuration inputs here. And they are then passed on to a meta node where a lot of the replacing the placeholder variables happens. So if I click on this meta node and scroll through the variable, the first one is, I think, system prompt template. Then we will find that now the user question has been inserted into the prompt, and this prompt is then used for the chat model prompter node. And this chat model prompter node is nested inside a recursive loop, and straight after the chat model prompter node comes another meta node that does another round of replacements and checking. So the reason why I've nested this inside a recursive loop is because most of the agents need to respond in a very specific format so that a certain state variable can be populated with information that the next agent may need to perform his task. And that is happening in this meta node after the chat model prompter, and only if the required response format is adhered to, then this recursive loop ends. Otherwise, there is another round of prompting where the agent is provided with his previous response and is reminded of the response format to adhere to and is asked to correct itself. Let's maybe now take a look at all the other inputs that there are. So the next one is an optional data workflow service input node. So this right now is not doing anything, it's just passing the data through. It's a placeholder to potentially later on enable that an agent or maybe a tool can provide a data table as an output, but that has not yet been implemented. The next one is a very important input table because it holds all the information about the state. So it is a list of all the state variables that you can find in the different prompt templates of agents and of tools. And it holds the current state of information so that if an agent gets to act and the agent needs to know what the user question is, this user question then gets injected into the corresponding prompt template. And after the agent is done with the execution, any state variables that are required to be provided by that agent will be extracted from the response and will be updated in the state before it's being passed out again. The next input table is I call it abbreviated message history. And this is also the table that is being passed as a chat history to the chat model prompter node. So this table does not hold the full responses of all the agents that we saw in the earlier demonstration. There's another table for that, but this holds the, let's call it status reports. And this way it is ensured that the agents do not get overwhelmed with a too long context window, which may confuse them in their decision making. That's especially important for the agent orchestrator. The next one is the so-called config input table. As you can see, this is being straight passed through to the output as well and therefore not really doing anything yet. The idea that I have here for implementation is that a certain number of input parameters can be passed in that drive, for example, the maximum amount of retries an agent has before the loop ends and an error is being reported. And the last table then is the full and formatted message history. So that is what we can see in this chat-like window during the demonstration. You can see the detailed responses of every agent, and you can also see that I've added HTML formatting to make it a little bit easier to read inside these chat bubbles. And after that, there's only really one thing that still has to happen, and that is that all these tables that get put in and that get changed are then outputted again to workflow service output nodes. And that is then what's coming out at the other end of the call workflow service node. And that is really how I can make sure that I only need one generic agent that can be used with different prompt templates and that can get called over and over again. And I think that is a very good point to wrap up this video. So I hope you enjoyed this update and demonstration. I will definitely progress in developing this. My goal still is to maybe release it at some stage as sort of a shared component that is a little bit easier to use so that other people can start building their own agentic systems and workflows as well, and maybe even their own tools.